we will talk about how to compute with numbers. In computer we have different data types, but the processor itself actually uses only numbers, or every data type is actually represented as a number in programming language or for the processor. And in the end, all the data is actually represented as zeros and ones for the processor. But it's nice to know that even if you have text or anything else, it's actually a bunch of numbers for the computer. And depending on whether you have integers or floating point numbers, the program acts differently with them. And in Python, let's repeat that the value has a data type and the variable does not. So it doesn't matter what's the name of the variable. What matters is that what's stored inside this variable. And in Python we have a function called type, which returns the type of the value. And here is an example. So we have different lines of code here, and every line prints out a different data type depending on what's put into this function, or what is the argument for this function. So the first one is int, which means integer. Then this is a floating point number. This is also a floating point number, although it is actually the same mathematically as the first one, so they both are 3. Now I can also pass here a variable, and the value of this variable, or the value where this variable points to, is taken into account. And here we can see that this number contains integer number. The same goes here. So we have a floating point number, and I can use variable to print out the type of this value inside this variable. So the function type shows you a data type. It's not very common to use it in your program, but still it's a nice way to kind of understand or see what's happening in your code. Sometimes you want to maybe understand what's the data type inside my variable, then you can use this function. And although 3.0 and 3 are mathematically the same, they are different data types for Python. So floating point numbers. Floating point numbers are not precise. So, for example, if you take 0.1 and add it 3 times together, the result is not 0.3 as you might expect, but it's actually something like shown here. So you have to be careful if you use floating point numbers, especially if you want the results to be precise. And also if you want to compare whether 0.1 plus 0.1 plus 0.1 is the same as 0.3, then the result is false, because they are not the same. They have a very small difference, but still this equation or this comparison returns false. So if it's possible, use integers. And for example, if we want to represent price in our program, we could use integer to represent, for example, cents, instead of representing euros and using floating point numbers. So instead of 4.3 or 4.30, we could use just 430, and it's an integer. And now if we add up, for example, 10 cents 3 times, we end up with 30 cents. But in this case, if we would use euros, we would end up with something like that. And then there is the problem, for example, if, I don't know, you're doing some banking program and you want to take this amount of money from the bank, but the user or the customer or the person only has exactly 0.3, then you cannot take it out because it's larger than the amount of money the user has. So there can be errors like that. So there are different operations we can do with numbers, and here are the basic ones here. So basically we can add, we can subtract, we can multiply, we can divide, we can take something into a power, we can take absolute value, we can do integer division, and we can also take modulo or remainder. So we will talk about those two last ones in more detail. So here's an example of different operations and what are the results. So you can expect the value of adding and subtracting and so on. Those are common. And also division and multiplication. There is actually no example for multiplication, but you can get the idea what's going on with the multiplication. And now the two last ones, the integer division and this remainder, we will talk about those in more detail. But before doing that, we will see about type and type conversion. So usually if the expression contains floating point numbers, all the integers are converted into floating point numbers. What's meant by that is that if I multiply two numbers, 5.0 and 2, the actual calculation done by computer or by Python is so that it converts this 2, which is integer, into a floating point number and then carries on the expression itself. The same goes with division and so on. To convert floating point numbers into integers, we can use function int, and no rounding is done if you use this function. So if you have 4.9, then it's converted into 4. So basically everything after the decimal point is just taken off. So even if it would be 4.999, it would still become 4. And you can convert vice versa. We want to get the floating point number from integer, then we can use function float. And in this case, just the result is like here. If we have integer 2, we will get 2.0. Okay, there's example here. Now we can also convert numbers from string. This is useful. For example, we ask user input and we want to use this input as a number, and that can be done. And we can convert it if the string has correct number inside it. So for example, if the user enters 12, then this is a string, and now to get actual integer out of it, we can use function int, or we can use float. In case of the float, there can be point, so the like decimal point, and but nothing else is allowed. So for example, if I have I don't know, some letters there or even space, I will get an error. So you have to maybe clean up the string before using those functions. But usually if you are certain that there is a number inside this string, then you can convert them into numbers as expected. And also I can turn an integer string into a float. Then basically you just have this .0 here. So let's see about the integer division and modulo or the remainder calculation. So if you have two kind of values or two numbers and we use division as kind of symbol, but two division symbols, then this is integer division. And what happens is that it actually returns a floor of the division. So basically we take the division and we take the integer part of it. So for example, if I have 10 and I want to divide integer divided with 3, what happens is it's just 3. So usual division would give us 3.3 and so on, but now this part is taken away and I get only the integer part. So that's the point of integer division. So we only have the integer part. And here is the example I draw on the board also. And in this case, if we have the expression where I have 10 and 5, which is due anyway, but here I get due, and the result is always integer. If I compare it with normal division, I would get 2.0 because it is a floating point number. In most cases, the result is a floating point number, even though it actually is divisible exactly, but it's still the result is a floating point number. And now let's see about the modulo or the percentage sign. So we have two numbers, and what happens is that we divide, basically do a similar operation, but what is left after the division, this is the result of this modulo operator. And let's see an example. So for example, we have 10, and we want to see what's the remainder if we divide it by 3, and we get 1 here. Why is that? So basically, for example, let's say we have 10 here, and now we are dividing it by 3. So we have 3 here, 3 here, 3 here. So not the ratio is not correct, but what's left over here is 1, and that is the result. So for example, if I have 10 and I want to see the remainder of 5, I would get 0 because it divides exactly into 2 and there is nothing left over from this division. And for example, let's say if we have 7 modulo 11, for example, then the result is 7, because I can take 0 times this 11 out of 7 and what's left over is 7. So this is maybe something you usually don't do a lot in mathematics, but it's very common operation in programming. So you will see this a lot. And here is the same example, basically same examples. In addition to basic operators we saw here or previously, there are a lot of different functionalities we can use in Python. And here are some examples. Square root, for example, trigonometric functions, logarithm, rounding up, rounding down, and so on. And to use those, we have to use module math. So there is a special module, or basically a file, where all those functions are defined, and we can use the functions from this file or this module. And this is built into Python. You don't have to write anything yourself. And to use those, we need to import this module. And this is done so, import math. Here's an example. So usually in the heading of our code, or on the first line or somewhere near that, we have imports. And here we import math. And now what happens is that it finds a module named math from the Python built-in modules, and it is included in our code. So now I can use different variables from this math, for example pi, the value of pi, or I can use different functions, for example square root here. So, and we cannot do it without this import. So after we import some module, we can use this module in our code to access different functionalities and so on. And yeah, we can access variables from this module, for example, by here, and functions, for example, square root in our example. Without importing, we cannot use those functions. Now let's see the order which is used to calculate our different expressions or formulas. So we usually follow the order from math, and first we use this power, or if something is taken into power, this is the first thing to do. Then there is multiplication and division, and then addition and subtraction. So basically the same as in math. And we can use parentheses to kind of change the order or give some part of the expression more importance or something like that. So the priority can be changed. So for example, if you have the given example 2 plus 3 times 4, so what happens is that the multiplication is done first. So we get 12 there, and then 2 is added. So we end up with 14. But if we want to do this addition first, then we have to use parentheses here. So now the 2 plus 3 is calculated first, we get 5, and then 5 is multiplied by 4, we get 20. So to sum up, in Python, value as a data type, the variable does not. Depending on the data type, the operations showed in those slides can give different results. For example, for numbers, if we add 2 numbers, they are added up mathematically. But if we would use adding for strings, we get a different result. So that's something to bear in mind. And also, depending, for example, if we want to add number and string, we get a different result. For example, we get an error and so on. But for numbers, we saw how the basic operators work. So the main 2 data types for numbers are int, or for integers, and float for floating point numbers. And we can convert between those using int and float functions. And also we can convert strings into numbers using those functions. And we can use math module, which has a lot of built-in functionalities or functions and variables, so you don't have to invent the wheel for some mathematical functions.